Hello everyone, I am Bhavishya and this is Achyut, and we are here to present this week's paper on automatic analysis of multimodal group actions in meetings. So before we start, let me ask you, when you look at a meeting, what do you think is the most important aspect of a meeting? If you would like to model it later, what do you look for in a meeting? Okay, okay. Yeah.
Action items.
Sorry.
Action items.
Action items. Yeah. So like
if we are meeting for a reason, let's say we are meeting for a homework assignment, then
right.
What would be the action items after that meeting? Like we would be working on data set, or
right.
we would be working on machine learning model.
Okay. Right. So kind of a major bit of the meeting. What were you working on? Kind of minutes of meeting. Right. So that is one aspect. To kind of narrow down the scope of the question, would you look at the individuals? Would you just monitor the individuals and look at their reactions? Or would you like to model the meeting as a whole? Would you like to model the meeting as what was the engagement level in the meeting? Or, what do you think? Should we model the individuals separately and have a model for all the individuals, or should we model the meeting as a whole, where we are trying to come up with some aspects about the meeting, about all the participants together? What do you think in that respect?
Individual details matter, but it also matters that how one individual actions are affecting the other one, and
right.
like reciprocate, like how they are reciprocating each other. So basically individual plus like how the entire...
Right. So kind of to say it in another way, you should be coming up with a model that models the entire meeting, but you should factor in the individual components as well. So they are kind of the so this is kind of a cause and effect. You analyze the individuals to come up with a model, modeling the meeting as a whole. So with that motivation in mind. Sorry. Just skipping it. So with that motivation, so this is the motivation of the paper. They're trying to model the meeting as a whole, and so the researchers in the paper state that the previous work has mostly been focused on monitoring the individuals. So when you provide a meeting, they will just model, okay, this individual was talking, this individual was, his gaze was this, at this coordinate at this particular time. But they weren't arriving at a complete top-down parsing of the meeting. But in research where there was this kind of top-down parsing, they were not involved with kind of spontaneous and overall behavior that we would like to see. And they were basically constraining the participants. So let's say in the area of surveillance, so they were trying to parse down the meeting in those areas, but the constraints, so the modeling of the interactions were basically modeling the constraints themselves, so which didn't have the kind of spontaneity that one would have hoped for. So the researchers then looked towards social psychology to come up with their hypothesis, which matches their hypothesis. And so in social psychology, we get to see that you have a kind of structured observation approach. So you're trying to come up with something like a basis set in linear algebra. So you have this mutually exclusive and exhaustive set of actions, and you can then model the meeting as a linear combination of them. And yeah, so it is kind of surprising that we're seeing that in social psychology, but yeah, that is one important aspect that they took away from it. And so that was done using coding systems. So there were two prevalent coding systems, which are process-based or task-based. So process-based would be something like a person is showing solidarity, how much tension, how much is he agreeing, and so on. And tasks are basically the individuals carrying out those things. So they're different ways, but basically their aim is the same, to come up with a exclusive and exhaustive set of events. And so there's also morphology of group interactions. So to come up with a top-down parsing, they also need to model how the interaction goes in, apart from the individual actions. So so this is where the importance of turn taking comes up. How much they are interacting, how well or how engaged is the conversation, and yeah, so auditory information would be important in this respect, but there are cases where auditory information would not be enough, where we would need the visual cues. So basically, if someone is talking, we would like to see the visual cues of the listener to see if he is engaged enough or not. So yeah, so these are the takeaways that I already discussed. And yeah, so we have the motivation, we know the social psychology behind it. So after this, they kind of define a computational framework so as to define so as to statistically model the meeting. So there are three components of this framework. So one is the group actions, where we directly take this concept of exclusive and exhaustive events and model them as group actions. And the second part is individual actions. So this is where we monitor each of the individuals. And the third is coming up with a model of interaction between these individuals. So the first one is the group actions, and it's a continuous sequence of exclusive events. So these are the events that they had come up with in their research. So the first one was monologues, users talking, one of the individuals talking to the group. Second was presentation, and someone is presenting. Third was whiteboard, and fourth was discussion, and fifth was note-taking. So discussion and note-taking these are more involved group actions. So in the research they had involved 4 people. So they had 4 channels for monologue and 1 each for presentation, whiteboard, discussion, and note-taking, for a total of 8 events. So can you guys think of any other events that can be added to this set of events that they had come up with? Sorry? Right, yes. Yeah, so that might be a format of meeting, question answer, yes. Anything else?
Someone falling asleep or?
No, I mean, yeah, it is kind of a broad question. So the thing is, and it's kind of a silly question, because the research started with the hypothesis that we have to come up with the exclusive and exhaustive set of events. So they have basically thought out of all the possibilities here. So the only way that you're going to add to these events is if you look at the meeting in a different way. So something like question answer, or or brainstorming, or something like that, or engagement level of a meeting. So basically trying to look down on a meeting in a different way. So yeah. Tasks. So this is brainstorming, information sharing, decision making, interest level of the group, etc. Yeah. So what do you think? Apart from parsing down the meeting in a top-down way, what other benefits do we have by modeling a meeting as this action set? Anyone has worked in the telepresence industry? So the reason for me asking that was that in a lot of places, the customers want that the meeting should be, you should be able to archive the meeting in some way, and you should be able to browse the meeting, you should be able to index the meeting, so that you go from one segment to another. So, okay, this is the monologue part, this is the discussion part, this is the presentation part. So it's very easy to browse and index and archive the meeting in this way. And yeah, so a lot of television companies do work in this space, so Cisco, etc. But yeah. So, so after we have this a model of group actions, so right now we have kind of defined the grammar of the top-down grammar that we're going to parse the meeting as, but individuals are not going to tell you that they are in a monologue right now. All you have is observations. So the individual actions are basically those observations, and if we are to come up with a meeting set which, or if we are to correctly predict an action set, individual actions are all we have, and we need to focus on them to get our action set correct. And yeah, so we have a set of observables, and so that's a vector of multimodal features at any given point of time, and with the help of that we are going to come up with a sequence of action sets that would correctly describe the meeting. So anyone here who can guess what model are we going to apply here?
HMMs.
Right. So this is a hidden Markov model. So basically you have some temporal sequence in the events, and you don't have the events as such directly, and you just have the observations. So the events are kind of hidden, and you still have the temporal information in those observations as well. So it's still Markov. So it's a hidden Markov model that would suit this kind of data we test. So the third part is the interaction model, where we basically come up with the HMM model, the parameters that would maximize this set of observations given our parameters. So we are basically maximizing this in this set of probabilities. So for doing that, as for we do generally for HMMs, we introduce a state variable, and we come up with, so we factor this joint distribution into two separate distributions, and we can then apply expectation minimization and come up with a hidden Markov model that will correctly give us the actions. Yeah, so basically we have this set of lexical entities of these actions, and we are going to model them correctly using a HMM, and yeah, so basically we are going to do this for all the meeting actions, and so any guesses on before going over that, once so right, I think a lot of you would probably know that already. So basically we are trying to find an optimal sequence of these submodel HMMs for the complete hidden Markov model, and Viterbi algorithm is the one which is the most popular in this regard. Yeah. So now we have the submodel HMMs. We have come up with an optimal sequence, but we are missing a key part here. We are still focusing on the individuals. We are still not modeling the interaction. So for doing that, we need to kind of focus on the modalities, on the different streams of the data, so that we can model the interactions as well. So before going over that, I would also like to ask you guys, so we have this exclusive and exhaustive sets of actions, which using the linear combination of which we will get the information about a meeting. What do you think we are lacking in this action set, especially with respect to real life? So this is a very nice theoretical kind of a framework, but what do you think is missing if you compare it to real life meetings? Alright, so in real life meetings, they are not going. The temporal boundaries are not going to be very clear. So yeah, you're going to. No one is going to be very okay. I'm presenting. Everyone be quiet now. So the boundaries do merge. So basically, we cannot say with 100% guarantee that this action set will be the most accurate description of the meeting. So yeah, so we'll come up. So the solution to that will come up later, but I just wanted to state this out. Yeah. So to involve streams, one simple way to do that would be that you merge all these streams together into one very big stream. So you don't really care if it is audio or video. You're just merging it together. So this is basically early integration. You're integrating the data beforehand, and then you're training an HMM over that. And so yeah, so you might need up-down sampling because the rates might be different, and you want to treat every frame the same way. So you might need some up-down sampling. So this is a very straightforward way of doing that. Maybe we can be more intelligent about this. So a more complicated way to do that would be to do it separately for each stream. So you might do it separately for audio and video, and then combine those HMMs into another HMM. Or you can treat the individuals as separate streams and then have an HMM for them, and then combine that into another HMM. So so here the key part is, when do you recombine? So there are two. So one way of doing that is, as I mentioned before, you have a state variable. You have these different state transitions, and you're modeling these states, and maybe you can recombine them after each state in the final HMM. So in that sense, it would be state synchronous. Sorry. In that case, it would be state synchronous. So basically, we're trying to say that the all these so the actions are independent of the states, and at any given state, this is a prediction that we are coming up with, and we don't really care if those states were dependent on each other or not. We are treating them as independent. One other way of doing that would be that for each single stream HMM, you model each possible state into a separate state in the new HMM. And so that would be more accurate, because that would have some asynchrony on the state level, which we actually want to model. And but yeah, so that is kind of intractable. I mean, not kind of, it is intractable because it grows exponentially in the number of states. And so you have these two extremes of having state synchrony and complete state asynchrony. There is a composite way of doing that as well. So in that, you just group all these states by actions, and then have combine all these states within these actions. So it is action level synchronous, but state level asynchronous, and there is kind of a middle ground. It is still exponential, but we can limit it if the number of states per actions are small. So yeah, so those are that is called the composite model of NM Markov model. So there are some other approaches as well, and my friend here will tell you about that.
So there are some other approaches in which we can design HMMs. So one is the coupled HMM approach. In this approach, to calculate the transition probability at a state, it depends not only just on the previous state of that stream, but also depends on the previous states of other streams. Whereas there is another way called the asynchronous HMMs, and in this we calculate the asynchrony by calculating the joint probability between the streams. But as we see, as the number of streams will increase, there will be an exponential increase in the time complexity. So this asynchronous HMM has a limitation in terms of the number of streams which you can model, and there are algorithms which are being currently studied to reduce this time complexity. And so in our experiments which we have performed for this, we were collecting both audio and visual data. For that we used 24 microphones and three cameras. Each meeting was scripted, like the actions of each individual were defined, and each meeting consisted at least of 5 actions. So this ensured that each meeting contained sufficient number of actions, and the duration of each action was sufficient enough for a hidden Markov model. And in all, we recorded 60 meetings for our study. For the feature extraction phase, we extracted 18 audio features. This included pitch, speaking rate, energy. And for the visual features, we have extracted 21 visual features. We extracted features for the head block, for the hand position, for the motion between the frames. And One very specific thing which was observed by extracting visual features were like the position of hands. So it was observed that people usually used to have crossed hands while listening to a discussion. So in our study, most of the participants were right-handed. So instead of going for both the hands, we just went for the right hand position. We calculated a block for that, and then we calculated the mean vertical position for getting the visual feature for the hands. This ensured a much more accurate representation in terms of the visual feature. So after the collection of this data, we have three subsets. So one is an audio subset for the audio data, video subset, and then if we classify data based on individual participants, there will be since there are 4 participants, there are 4 subsets in that category. And after data collection, we use the following HMMs to classify and combine our streams. So one is the early integration. Then for the participant streams, we use multi-stream as well as coupled. For audiovisual stream, we also use multi-stream and coupled. And then, since asynchronous HMMs has a limitation in terms of the number of streams they can handle, we only tried asynchronous HMMs with the audiovisual streams. Since for participants there are 4 streams, and it would cause an increase in exponential time complexity. So after using the HMMs, we used metrics to classify or check the performance of our data. And the 2 metrics which we have used in our study is the action error rate and the frame error rate. So action error rate is defined as the number of insertion errors, deletion errors, and the substitution errors divided by the total number of ground truth labels. So insertion errors are like while we are classifying using an HMM, if there is no action and we are specifying a particular action, then that is an insertion error. Deletion error is when we are not able to recognize a specific action, and substitution error when we are recognizing an action for a different action. So these are the 3 types of errors which we used for the action error rate. And for the frame error rate, it is just the number of incorrectly labeled frames which in the video stream. So based on these 2 metrics, which of these do you think is the most significant for evaluation of group actions in meetings, like action error rate or the frame error rate? What do you guys think?
I think it's probably action error rate.
Yeah, you are right. Yeah. So what is there? Since in our study, it is important to determine the correct sequence. So action error rate is a much more important metric. Like we need to get the correct sequence of actions. And since our transitions are not well defined, then action error rate also helps to support that. But we also used frame error rate. So that we can get like the temporal alignment of our classification is correct or not. We can get that information. Yeah. So these are the results which we are getting. First, we have checked the performance based just on the individual streams. We can see that the audio only performs best in terms of audio, video, and individual participants. Then after that, when we check based on early integration performs well better than all the other 3 in terms both of the action error rate and the frame error rate. And then we check for both the audiovisual and the participant streams, and we have found that asynchronous performs better in terms of frame error rate, in terms of all other streams, whereas for action error rate, early integration is giving us the best results. So in our further study, to get a better analysis of each of these features, we have used a confusion matrix. And in confusion matrix, we are plotting each of the group actions like presentation, discourse, monologue, and we are checking our accuracy in terms of insertion errors and deletion errors. And so we can see that audio only streams provides us good accuracy, but only in case of note taking, it is not able to give us sufficient accuracy. Whereas for video stream, there is much more errors as compared to audio. So what do you think? Like we have done the classification based on both audio and video streams individually. Like are there any group actions which you can think of that will benefit if we combine both the audio and the video thing? So yeah, one thing can be like the note taking. We have seen that note taking is not getting good results either for audio or for the video. So one thing that can definitely be explored is that if we combine both of it, what is the performance on the note taking? So similarly, this is the result for participant only stream, and this is then the result is for early integration. So we can see that after early integration, we are getting much better accuracy for most of it, it is able to identify note taking with sufficient accuracy. So similarly, if we have seen that other streams do not give us good results, and only for frame error rate, H1 performs significantly better than all other ways of classification. So these results helps us to hypothesize that we should definitely explore asynchronous hidden Markov models for participant streams, but we also need to check that our algorithm does not goes into exponential time complexity, and for that we need to find a tractable training algorithm. So we checked our system on real-time meeting data. We collected around 1 hour of data, and there were 4 participants. Each data was labeled by 2 independent observers, and if they did not agree, then the author of the study helps us to read what is the action taking place, and we checked based on these 3 H1 models. So we can see that there is sufficient accuracy in our results. Like we are getting a classification rate of 80%. So this means that our hypothesis, like group-based actions, term-based actions, helps us to recognize group meetings, is sufficiently accurate. And so these are the key summarization of the findings from this paper. There is definitely a benefit from the multimodal approach, and there is no significant asynchrony between audio and visual streams. As you can see that there is no increase in accuracy, but there is definitely evidence of asynchrony between the participants, and which needs to be explored further with the AHMMs.
Great, thanks.
Yeah.
Next group, race. The next group was race. Very quick. Thanks.
Okay, so hi everyone, my name is Ali, and my friend Hadis is going to present the paper probabilistic multimodal approach for predicting the listener back channel. And as you can see, one of the authors is Jonathan Grach, who was the guest speaker in our class earlier. The outline of our presentation is this. I'm going to start with the introduction, why this topic is important, why we are doing this, and what we are looking for. And then I'm going to talk about the main procedure which is followed by the researchers here to come up with the prediction model. And then Hadis will continue with the details on data collection and the experiments, the features which were selected, and the parameters which were used to evaluate the models. And then at the end we will have the results and also a few points to discuss more. So in this class we have been talking about the human-computer interaction and the fact that for some applications it has to be natural for people to accept it and easily use it, and for that reason development of natural and engaging virtual humans have been the topic of research for years now, and we have seen some examples of the virtual humans which are developed at ICT or other research centers. And one important aspect of interaction is conversation. So when we have a human-to-human conversation, you know that it's very dynamic, it's very spontaneous, and it not only includes the spoken words, but also a lot of different multimodal features like facial expressions or gesture from either the speaker side or from the listener. So in general, we call these extra signals which are produced by either of these involved participants, and this is very closely related to the concept of listener back channel. So can anyone tell me, because the professor talked about it in the last time, can you remember specifically what is listener back channel? What does it mean? Yeah?
Some kind of feedback from the listener, like head nod.
Exactly. That extra signals which are produced by the listener, like head nods that mentioned, these are called listener back channel. And these back channels, these feedbacks have many implications, and they can give us a lot of information in terms of the listener is like involved in the, engaged in the discussion, or if he agrees or disagrees with the speaker, and if certain emotions are like causing the are happening in the listener as a result of what just the speaker said. And you can imagine how important these signals could be in a like important negotiation or things like that. And there are some reasons that makes the task of predicting and generating these feedbacks difficult and challenging. The first one is that these signals are produced spontaneously and in the middle of someone else talking, and also they include a combination of verbal and non-verbal behaviors, which have to be considered when we are trying to generate or simulate this kind of listener feedbacks. So the big picture in this research, the main objective is to extract some multimodal features from the human speaker, and using some algorithms and methods try to predict and generate these feedbacks and back channel in real time. And actually these methods and algorithm is what we will talk about in the following slides. And since we are talking about development of virtual humans, it makes sense that here the speaker should be a human and the listener should be a virtual human. So this is the main consideration and the procedure which the authors followed to come up with the prediction model, and I'm going to go through every one of them now. Since we are dealing with time series and the sequence of data points is important for us, a sequential probabilistic model is used here, which takes a sequence of observation features as input, which are simply the speaker features. And as the output, we'll have a sequence of probabilities, which is the probabilities of back channel happening. And two popular sequential models which we talked about are used here, hidden Markov model and conditional random field. Also, in order to capture the rough relationship between the speaker features and the listener back channel, there are a number of encoding templates which are designed and used in this study. So we have some situations where, for example, there is a delay between the happening of a speaker feature and the influence, and that's actually a very difficult situation for the model to learn. In order to deal with those kind of issues, these encoding templates could be very helpful. And here, three different types of encoding is used: binary, where only the duration of the feature is important; step function, which is a more general form and has two new parameters, width and delay; and finally ramp function, which has a linear definition for a specific time and is helpful for situations when the influence of the speaker feature on the back channel changes over time. And these are the 13 templates which are developed and used in this study. Again, as I said, we have three types: binary, step, and ramp. And you can see that we have two parameters, width and delay, with different values for each of them. So these are the representation of the features which are going to help the model learn those difficult situations. And also, in order to reduce the number of features and preventing the model from becoming too complex and reduce the risk and danger of overfitting, they have introduced an automatic feature selection method, which has been done in two levels: individual feature selection and joint feature selection. For individual feature selection, we assume that each feature independently can cause the back channel to happen. And for that, they have started with considering a statistical coherence, which simply means the number of times that the feature happened and caused the back channel to happen too. And after that, reducing the features to 50, they consider the performance evaluation, and they just train the model with all those encoding templates. And they just pick the top 12 individual parameters here. And after that, they consider the combination of the features. So the idea here is to find those combination of features which complement each other in the best way and you have the highest performance. And for that, they just use the best features that they come up with in the first step, and using an iterative algorithm, they find the best combination of like groups of features up to 4 features. And after that, they did the first 3 steps. Now they have some output probabilities from those sequential models, which the good thing about them is that they are smooth over time, so it's easy to find the peaks, the local maximum at different points, and for each peak, for each back channel opportunity, we also have the associated probability. So here you can see we have 3 of them, and by defining the threshold value, we can decide how many of these can happen. So here you see we have 3 of them, but only 2 of them has happened, and we ignored the one which is the minimum one. And yeah, with that, Hadis will continue with the experiments and other details.
Okay, so I'll start with the data collection and the performance evaluation eventually. So in this experiment, they had 50 different pairs of couples that were selected, and they recorded face-to-face conversation. So it's like monologue, one person is just speaking and the other person is listening. So between couples, one of them was randomly selected to be the speaker, and one of them was randomly chosen to be the listener. So the speaker was asked to watch a video and then tell a story about the video to the listener, which has no idea about the video. During the conversation, just like the monologue, voice and upper body movements of both participants are being recorded. So here, this is how the setup looks like. So as you can see, there are like cameras in front of the participants and like one up ahead. So the speaker starts telling the story, and the features like the back channels of the listener is being recorded at the same time. So the important thing about this is that the topics that are selected for these movies were somehow arousing emotions in the listener. They're not some like typical subjects. They're like some unexpected things that have happened, so that you can get the most reactions out of the listener. So the 50 test cases were like performed, and after that, the features that were extracted were these are the visual, the vocal features. For instance, the gradual drop or rise in the intensity of the speech, or like the vowel volume, or like the downslopes in the pitch. So besides these features, they also have some manually annotated features. For instance, the way that the speaker is actually pronouncing the words. For instance, if he has like field pauses, like saying when he's speaking, or for instance, when he tries to have emphasis on some parts of the word, like say exactly instead of saying exactly. So it's like even those emphases are being captured here. And like for instance, words spoken with rising intonation, like when there's question mark, or when there's like end of an utterance. So these are all the manually annotated features, as well as the ones we talked about. And lastly is the speaking looking at the listener. So that's the only visual feature that was being recorded. And so this is being recorded by measuring like the coarse measurement of the eye gaze of the speaker looking at the listener. And this is binary. So it's like, is he looking like staying at the listener or not? So that's the only visual feature that was measured. Now it comes to the evaluation of the performance of the model. So they're using F-score. I think many of you are familiar with F-score. So it's like the way of testing how accurate your model is. And it's being calculated by the weighted harmonic mean of precision and recall. Does anyone know what do we mean by precision and recall?
That's an important question, by the way.
So how many correct observations are made out of all the how many correct observations are made out of all the actually correct ones? So that is recall. And precision is how many correct observations are made out of all the possible observations.
Oh, the positive or the alarms that doesn't make sense.
Yeah. Okay. Great. So let's look at this graph just to like refresh your memory. So here, as you can see, by precision, it means out of our data points, how many of these selected data points are relevant. So you can see it's like the green portion or the whole like green and red, which is like both positive and negative portions. And recall means how many of these items that were selected are actually relevant. Okay, so it means like only the green parts for each other. So the graph is like a good representation. So now going back to our like study, what do you think? How do you think you can define the recall and precision in our study? So, what will be the definition of precision and recall?
So we're looking to find what motion or like behavior? Back channel. Right. So
Okay. So by recall we mean, so as we mentioned, recall means how many of the relevant data points are being captured by the model. So here means the probability that the back channel produced by a listener is predicted by a model. And here precision means the probability that these predicted back channels are actually corresponding to actual listening. Okay. So these are the two like indexes that have been used. And so eventually they have done some comparisons for joint versus individual feature selection. As Ali mentioned, they have done focus on joint feature selection. The assumption was that that will result in a better performance. As you can see that for only individual feature selection means that you have only vocal features. You have like 0.22 rather than the joint, which you combine one visual feature as well. You're improving the overall system's performance by like 4%, 2%. And then the other thing is that, so this paper is not like a very recent, it's for 2010. So they also made a comparison with the previously studied methods that was being used, which was the rule-based method. So in the rule-based method, the feature selection is not automatic as they're doing it here, and it's not probabilistic, so it's just not manually selected. So comparing with the most recent approach at the time, they had improved significantly, like the performance of the model has been improved significantly, having probabilistic and automatic feature extraction approach. Lastly is validating the multimodality of this approach. So they also made a comparison for between having a unimodal method versus multimodal. So for unimodal you only have the vocal features, while in multimodal you also is combining with the visual ones. Here our visual was the speaker looking at the listener. Yeah, as you can see, again, they were able to improve the overall performance of the model. So now we have some discussion questions. The first question we have is that what do you think are the advantages of actually predicting these nonverbal feedback? So why people are studying the listener's feedback, like the back channels? And can you think of any other applications other than what we just talked about?
So if you have a model like this, how we can use it? In what other application we can manipulate or change this model to?
For example, to check if the communication is effective or not. For example, when we are talking to somebody, if he's giving a feedback and you have a sense that the communication is happening, like he's basically understanding that or not. So in order to see if the communication is effective or not.
Right, yeah.
We can use this to assume attention or interestingness of the topic.
If he's paying attention.
You mean by analyzing the listeners?
By analyzing how the back channels are provided by the listeners, we can see the effectiveness of the speaker in such kind of applications.
I think in a virtual interview or any virtual interview process it could be.
Yeah, exactly.
Okay, great. So second question is, how do you think the design of this experiment we just talked about could be improved? What do you think are the shortcomings, the experimental, in terms of the design of experiments that we just discussed?
one thing that I can say is that you have something to say? Yeah.
One thing that I noticed about the experiment setup was that everyone was watching the same sort of videos, so we never covered like a change of domain sort of thing. So like for example, if someone is telling maybe a fictional story or so, it was always a serious term that the speaker was talking about, so maybe listener is more sensitive to the domain than just the speaker. So
yeah, that's a very good point. Yeah, the theme of all the videos were sexual harassment, so it may just cause a specific type of reaction and back channeling listeners, which might not be correct for other situations. The last one?
Okay, so we have a short video, and then we have our last question. Okay, so as you can see, we have two people with different personalities, with different level of emotional expressiveness. So they're both watching a scary movie and they have different way of expressing their feelings. So our question is that how do you think we can address this problem of different degrees of expressiveness in the model? So assume we have two different virtual humans and we want one to have like a reserved kind of personality and one of them like has more expressive. So how do you think this can be actually implemented in the model?
You can use the standard deviation basically, how much they are changing throughout the process. So we can take like, for example, the person one, how much she has changed over the course of the video. You can study that. So basically study the standard deviation instead of studying the actual value.
But in terms of this model where you just want to produce back channel, it might be a simpler method to do that.
And I already talked about it in my section. So, do you wanna?
Yeah, so as you can see here, this is like the function, the smooth function that we talked about. These are the probability of these back channels. So we can, the threshold that we can choose, it can be adjusted like the way that we want which back channels to be selected. So we can have it like if it's like the threshold is here, only these two will be chosen, but you can actually have your threshold like here so that you have like the wider range of back channels. Okay.
Awesome.
Thank you for your attention.